Special relativity. Length contraction. Assume that a light wave is emitted at point M. The light wave travel equal distance at both direction to trigger two bulbs located at an equal distance from the point of emission. Both waves are emitted at the same time and travel to meet axis x' at two different points A' and B'. What is the measured length of A', B' relative to K'? Note that axis x and x' coincide, but they are shown as separate axes for clarity purpose only. Since all clocks in frame K are synchronized, TA equals TB equals T. The waves reach point A' and B' at time t relative to K. And, at time T'A, T'B relative to K'. We apply spacetime transformation at points A. And we apply spacetime transformation at points B. The length A', B' is obtained by subtracting x'B minus x'A. The length of the ruler delta x in frame K is given by the formula delta x equals 1 over gamma times delta x'. From the standpoint of observer K, we can read this law as follows: the length of a ruler measured at the same time and by synchronized clocks in K is shorter than the length of the ruler measured at two different times and by non-synchronized clocks in frame K'. From the standpoint of observer K', we can read this law as follows: the length of a ruler measured at two different times and by non-synchronized clocks in K' is longer than the length of the ruler measured at the same time and by synchronized clocks in frame K. The difference in time reading in frame K'. Delta T' equals negative v square over c square time delta x'. The coefficient gamma is always multiplied with the ruler length delta in the synchronized frame. The coefficient 1 over gamma or gamma to the power of negative 1 is always multiplied with the ruler length delta in the non-synchronized frame. From these equations it is clear that the length delta x' in the non-synchronized frame K' is bigger than the length delta x in the synchronized frame K. Or the length delta x in the synchronized frame K is shorter than the length delta x' in the non-synchronized frame K. The previous statement is more frequently used for length contraction. To understand why this difference in time is negative, the next train problem will show us why. The conditions according to which we apply the length contraction formula are: the short length delta is the length of the frame with synchronized clocks. Length delta' is the length of the frame with non-synchronized clocks. The coefficient 1 over gamma or gamma to the power of negative 1 is always multiplied with the ruler length delta in the non-synchronized frame. Or the coefficient gamma is always multiplied with the ruler length delta in the synchronized frame.